All right, guys, we're recording. So anyway, let's go to the homework first. Actually, let me go over the lesson, the video lesson from the other day, from yesterday. So these are my solutions for the classwork, and they're already up in school, G2. So y equals a times x minus h squared plus k. That's a formula you need to have kind of just ingrained in your head because we're going to be referring to it often today and next week and the week after. A represents a vertical stretch or compression. If A is bigger than 1, that is, of course, stretch. If it's between 0 and 1, it's a compression. Now, if A is negative, then, of course, it reflects about the x-axis. And to kind of offer a correction to the stretch, it's really the absolute value of A. Because what if you have -2? There's actually going to be a stretch that reflects about the x-axis. Or what if A is -half? It's actually a compression, but reflects about the x-axis. It's really, truly the absolute value of A that you would have to look at for compression and stretches. Jack, go ahead. No, bigger number would actually stretch it. Vertical stretches it, yeah, because it makes it more steep. You think of horizontal, it's vertical. We haven't done horizontal yet. We will down the road, but for now we're just sticking with vertical. But you're not wrong in thinking of that way either. But in terms of the factors, you really want to think of vertical because now you're squaring on the inside, so it gets a little confusing to think of a horizontal stretch or compression. H is E's horizontal shift, K is E's vertical shift. So we're going up or down, that's K, that's on the outside. We're going left to right, that's H, is on the inside. So that's what's happening there. And the vertex is actually identifiable. The vertex is H and K for the X and Y coordinates of the vertex, respectively. So once you have an equation, like in the case of, like, say, F, right? You have X plus 3, so H is -3. That's X coordinate of the vertex. K is -8. That's a Y coordinate of the vertex. So if you were to plot F, your vertex is -3, -8. And you know, if you open up or down, depending on the A value, A is the leading coefficient or the coefficient in front of X squared. So if it's positive, opens up. In the case for all of them except for E, of course, opens down. And then stretching or compression, if the A value is bigger than 1, or the absolute A is bigger than 1, that's a vertical stretch. If it's between 0 and 1, it's a vertical compression. So that's all filled out over here for you guys. And then on the last page I liked a lot because this was not given to you in standard form. Sorry, not given to you in vertex form. It's given to you in standard form. Standard form is ax squared plus bx plus c. That could be a little confusing, but if you can factor it, that's why I spent all the time factoring unit 1. And by the way, that's why you guys did a bunch of factoring in middle school. We beat it into you guys because it has to be a skill that's more second nature now. So if you were to factor it, you get 2 times x plus 5 times x minus 3. Now you can identify where it crosses the x-axis, right? -5 and 3. Halfway between is going to be the vertex because you have symmetry for parabolas, right? Halfway between is -1, so that's the x coordinate of the vertex. Plug it back in the equation, you get the y coordinate of the vertex. And I notice this is going to open up because there's 2 as a coefficient for x squared. It gets stretched by a factor of 2, that's fine. But I can't identify the vertex until I put it in vertex form, or if I factor it, then I get closer to vertex form. Once I have the vertex, I have the x-intercepts, I'm golden. I have my graph, and then I can state the vertex form, and the A values stay the same between the two. Between standard form and vertex form, they stay the same. So that's the lesson in a nutshell that I did in about 3 minutes or 4 minutes. So I know I spent half hour on the video. Now let's talk about the homework. The solution key is up. It's right up. I'm going to try to give you guys solution keys in advance. So if you guys get stuck, I mean, of course, don't just copy the solution key. I mean, I'm going to check your homework to make sure you're showing some work. But if you get stuck, it's good to have the reference, right? So here are all the answers for the regular problems. And if you want you guys to do extra problems, the extra problems, again, I mean, it's up to you. But if you are looking to maybe do pre-calc AB honors, or you want to get a better grade, you want to do really well, the extra problems are there for you as extra practice. Or you want to save them for a test, that's fine too. By the way, that's actually a great way to save for a test, the extra problems. Like, so maybe if you don't do them, but you save them for the test review, that could work too. Anyway, I'm going to keep publishing for this for you guys, so you guys have that that support system. Any questions you guys want to ask about regarding these problems? The homework actually is projected right here. So any of these questions you want to ask about that you're stuck on, it's up to you guys. You could just let me know anything you're stuck on. And we're not doing homework quiz today, by the way. We'll do homework quizzes every day, every time we meet next week. Every time we meet next week, we will. But today, because I was not here yesterday, Monday we just started a new unit, so we'll get back to by next week. But anyway, any questions? No? We're okay? All right. How about 40? That's review of old stuff. No? No questions? Okay. The answers are all here. And the extra problems as well, the answers are all there. No? Okay. You guys are easy. Okay, we're going to start the new topic for Tim. Let me pass it out to you guys. Just like last time, I'm going to give you guys a homework as well as extra problem. And these notes are going to be a little bit lengthy, but we'll try to get through as quickly as possible so you have time to start homework. And they're right here. Here we go. By the way, I now understand the lunch line, how crazy that line is. When did that start? They had the rope that goes around this year. Wow. How long do you think I got lunch? It looks like like 5 minutes. It looks back. 30? 30. It looks crazy now. I do that. I do. I didn't see him on. Well, I can see his hands up. All right. Okay, cool. Let's get started. How to rewrite in vertex form. Okay. So we have this, guys, quiet, please. And we want to get to this, right? So this is where you start. This is where we want to end. We want to end with vertex form. Now, if you have the x-intercepts, awesome, right? However, what if you cannot factor? Right? You can't factor all the time. Or what if you can't tell what the x-intercepts are? Same thing, right? So we need another technique that's more foolproof or universal, so we can always get from standard form to vertex form. The process is called completing the square. Have you guys done completing the square in Algebra 1, perhaps, or last year? I don't know. So it might be an old topic, which is good. If it's new, that's fine too. Sometimes it's introduced for the first time in Algebra 2. But this is going to be the key step, completing the square. Okay, that was a crappy looking star, but just go with it. Very, very important. How do we do this? Okay, before we talk about the exact process of completing the square, it helps to actually know how to make a perfect square. So perfect squares, what are perfect squares, by the way? Just give me a number. That's a perfect square. Great. What else? What else? 4. 25 and so forth, right? What makes these so special or so unique? If I square root them, what do I get if I square root them? You get what? You get a whole number, right? So basically, the perfect square, the square root is a whole number. That's what makes them so special. The square root is a whole number. So if we take a look at over here, let's look at this box. What can I pull out of the first row here? What's common between these two? X. And let's look at the first column. What's common between these first two? X again, right? And what would you multiply to X to get to 4X? Yeah. So you have to put a 4 here. So the way this box works, you multiply these two together. What's X times X? X squared. What's X times 4? 4X, right? And then what do you think I'm going to put down here now? In the lower left corner. 4, good. Yeah. So what this means, what goes in that final box? Perfect. So what this tells me is that X plus 4 times X plus 4 equals X squared plus 8X plus 16. Or X plus 4 to the second power equals X squared plus 8X plus 16. Right? Because these are identical. X plus 4, X plus 4. These are the same thing. So you can write as X plus 4 squared. And when you combine all this, what do you get? X squared plus 8X plus 16. So what you need to do is make this look like this. That's our goal. Is to make whatever you're given. So let me write this as a text box so it's clear what I'm asking you guys to do. The goal is to make the given trinomials, I know spell, sorry, look like a perfect square trinomial. And what's a perfect square trinomial? A perfect square trinomial is when the first term and last term are perfect squares. Is x squared a perfect square? Yes. What's square of x squared, guys? If I square root x squared, what do I get? X, totally. If I were to square root 16, what do I get? 4, right? And if I were to FOIL x plus 4 with x plus 4, what do I get in the middle? 8x. More exactly, it's actually this. A perfect square trinomial. Go back to purple. A perfect square trinomial. I know I'm being a little long-winded here, but I think we need it. A perfect square trinomial looks like this. A plus b raised to the second power equals a squared plus 2ab plus b squared. That is a perfect square trinomial. Anything that takes on that form. So what's happening in the middle? You're taking the square roots of a squared and b squared and double. So here we had a 16, right? Here we have 16. So what's square of x squared x? What's square of 16 is 4. When I multiply and double it, what happens when I multiply these two and double it? I get 8x, right? So that's what's happening when you're doing perfect square trinomials. So let's try this box thing more times. We'll actually do the complete square in the next examples. So here you have 9, right? What's square of 9? So let's put 3 and 3. There we go. But it's going to be 3x, 3x. Because x times x gets you x squared. X times 3 times x times 3 gets you 3x, and 3x, and 3 times 3 is 9. So x plus 3 raised to the second power gets you x squared plus 6x plus 9. There we go. 9's a perfect square. X squared is a perfect square. The middle makes sense because if you square root 9 and get 3, what's 3 and 3? 6. And it gets you the same thing as x plus 3 raised to the second power. Gets you the same exact thing. All right, let's keep on moving. Okay, so you want this to be perfect square trinomial. Okay, you want that to be perfect square trinomial. What do you think C has to be to make that happen? 16, good. And if that's 16, what's H going to be to make this work? -4, exactly. Because x squared plus 8x plus 16 is going to equal x plus 4 raised to the second power. They're going to be the same thing. So your C value is 16, your H is -4. So a lot of it is just trying to see the patterns and just go with it, right? That's really what we're trying to do. We want these patterns to be more natural, right? Like we naturally just see these patterns. Like, okay, I have an x in the middle, half of 8 is 4. That's one way of thinking about it. Take half of 8, right? Half of 8 is 4. What's 4 squared? 16. You can think of it like that too. That could work. So let's try this again. Let's look at 8x here, right? Take half of 8. Then squared. What's half of 8 then squared? 16. Good. Excellent. So what you're going to do is you're going to change this to 16 minus 6. So we're going to write this now. X squared plus 8x plus 16 minus 6. Is that the same thing as the original equation? Yeah. Because 16 minus 6 is 10, right? But what this allowed me to do is I focus on the first 3 terms, right? If I focus on the first 3 terms, how can I rewrite that as a binomial squared? Yeah, thank you, Jack. Excellent. Excellent. And there you go. I just magically turned this equation perfect square. So this is called completing the square. What you do is you're making this x squared plus 8x a perfect square trinomial. You're replacing a 10 with 2 numbers. 2 numbers that subtract the 10. but enables us to pattern. So now you get a vertex. What will be the vertex step, by the way? What will be the vertex what I wrote in green? What's the x squared of the vertex, guys? You're going 4 to the left. Sorry, I know my left is different from your left. You're going 4 to the left, and now we're going up or down, guys. The -6 on the outside, what does that mean? Down by 6. So now I got the vertex. -4, -6. And just to be sure, let's go to Desmos, right? If I go to Desmos, y equals x plus 4 raised to the second power minus 6. Okay, there you go. What if I type in the standard form? Y equals x squared plus 8x plus 10. They're the same thing. Right? If I turn this one off or back on and this one off, there you go. They're the same thing. Okay, let's keep on moving. We're gonna do this a few more times until you guys get it.
Yeah.
Okay, so this is drill and kill, but you guys need it. So I'm gonna tee these up for you. I'll at least tee up A and B, and have you guys try C and D. Let me tee these up for you guys. Using a golf term there. All right. So y will equal x squared plus 6x plus, and for B, y will equal x squared minus 4x plus, Davis, go ahead. You have the answers?
No.
So what you got to do is take half of 6 then square it. Same thing here. Half of -4 then square it. Sorry, I can't write. Guys, stop it. What are you guys doing? Thanks. All right. Half of 6 and squared. What's half of 6 then squared? 9. What's half of -4 then squared?
4.
4, right? Okay. I know you had it, Ellie. I know you had it. Okay. Now, here's the deal. This has to equal 7. This has to equal 11. What would you do to get to 7? -2. And what would you do to get to 11? Yep. So how am I going to write it? Y equals x squared plus 6x plus 9 minus 2. Y equals x squared minus 4x plus 4 plus 7. And let me highlight the stuff that we're going to factor. Okay, we're one step away from getting this done. Okay, what are you going to put in that first set of pencils here? We have x squared plus 6x plus 9. X plus 3, good. Out here, no? Close. X minus 2. X plus 3 squared. X minus 2 squared. Okay, you guys try C and D now. Try C and D. Following what I just did for A and B. Okay, following what I just did, try C and D. It's gonna be a little tricky with the odd numbers for X, the coefficient of X, a little tricky, but I have faith in you guys. Ask questions if you're stuck. Help you guys out. There you go. It's yeah, I mean, that's how I would have thought it, but I guess something I'm just asking. But yes, totally. If you got it, I'm not gonna hold it.
Okay.
So against then you got square.
65 hours. These squares like fractions. Good. That's what I mean. So you can be adding 25 over 4, but then forget the number. The last number has to be 2. So that's a little tricky. It's a little tricky. Yeah. Look, that's right. You have actually, that's been negative. Look, all this. I got this. Yeah, we still need this has to slow down. Just like how the next.
Because you're how did you get 6.25? Tell me how you got 6.2.
Yes, I think 25. Perhaps this little trick.
No. Number.
And then last one.
That's what I want to do.
No, no, that's right.
Because then
That's where.
What's happening?
No. Why did you write that? I didn't. No, I didn't. Oh, because it's half of 5 squared. So that means half of 5 squared. That's what you have to do.
It's just using
What?
the reason why we write like this is you do square root of x. I know it's a little tricky for fractions. I'll just mess it up.
Squaring. Yeah. Yeah, no. Have you seen a guy with a like You don't need to know that.
See really quickly. I have my sandwich. And then I'll back to part D. Okay.
What's -7 divided by 2? Is it?
So part C. Oh, pencil, yeah. Okay. So part C, guys. Here we go. So you take half of 5 and square it. So you have 5 over 2 squared, which is 25 out of 4. Or 6.25. Some of you guys wrote 6.25. That's totally fine. But I'm going to stick with 25 out of 4. So you have x squared plus 5x plus. Now, this part right here is the part we have to be really careful. 25 out of 4 minus something has to equal 2. Because you need all this equal 2. So what do? Well, you could change 2 to 8 over 4. So what number would you subtract by 25 fourths to get to 8 fourths? Or 17 out of 4. Same thing. So now that's 17 out of 4. So it's gonna be x plus 5/2 squared minus 17/4. Okay. I do feel same thing. Same thing. Yeah, actually, so you know what? You know what? I'm with you guys on that. You know what? Let's back up a little bit. I'm going to be very flexible here because I want to make sure you know, meeting guys where you guys are. That's my job as a teacher, right? Whatever makes sense for you guys. So, yes, let me back up a lot, actually. All right. Let's just erase the whole thing. What am I doing? All right. So, yeah, 1/2 of 5 is 2.5. We know that, right? And if you square that, that is kind of hard to square, but it is 6.25. Use a calculator, which I'd be fine with. Use a calculator. It's totally fine. 6.25. Now, what do you subtract from 6.25 to get to 2? I think you guys said 4.25. Does that make sense? So then you'd have x plus 2.5 squared minus 4.25. And that works. That actually would work because your vertex is negative 2.5 comma negative 4.25. Totally works. Let's do that again for D if you guys are comfortable with that. What's half of negative 7?
3.5.
Cool. So we're going to have x squared, and then you got to square that, which, yikes. Can someone help me out with that one? I'm sorry, repeat that, Sophia?
It's positive 12.25.
You multiply negative by negative, right? It's okay. It's all right. So you have x squared minus 7x plus, now guys, quiet please, thank you. So that's going to be 12.25 minus what, guys?
Minus 10.25.
Excellent. Excellent. Good. Hey, guys, Pearsons are off. Thanks. I feel like I'm watching my 6 and 4-year-old kids, so thanks. Awesome. All right.
Minus 3.5 squared.
Minus 10.25.
10.5.
Perfect. Perfect. Good. And that works. Or you can write 41 out of 4 if you so desire. Same thing. So, okay, good. Excellent. All right, let's move on, guys. I think we're ready. All right, let's look at the third page. And then the last one's just a summary, just so you know. So it's really just 3 pages notes. Ellie, go ahead. Of course, yeah. All right. So now, coming back to this function from the video from yesterday, right? She has an idea. What if we divide the function by 2? The a value, can we do that? Technically, you could. You would have to say this then, y over 2 equals 2x squared minus 4x minus 30 over 2. You totally could do that, but remember, whatever you do to one side, you must do to the other side. Okay, fair treatment. Whatever you do to one side, you have to do to the other side. So the answer is yes, you can do that. So then let's look at the net part B. Wait, says Lay, if I think I pronounced it right. What if we decide to divide the function by 2, find the vertex from the multiply, blah, blah, blah. So let me do this with you guys. So y over 2 equals, so what happens on the other side after you divide by 2? What do you get on the other side? X squared. And can I factor that? Or actually, before I factor it, we want to complete the square, actually. Okay, what's half of negative 2 then squared? What's half of negative 2 then squared? 1. Good. So I'm going to write this as plus 1 minus what number? One minus what number gets you negative 15? 16. Good. So it's the same thing. Let me get rid of the circles. That's a little confusing. Let me get rid of all this also. That's the same thing, right?
That's no different. Negative 15 is 1 and negative 15. Why do I choose that? Because I think half is the square. That's the one thing you have to remember. You have to remember that. You can't get away from getting around that. You have to half of this middle term and square it. Not hard to do. It's negative 1 and square is 1, right? It's not hard to do.
But then you write negative 15 as 1 minus 16. So now what do you got? You got x minus 1 squared minus 16 y over 2. And if I bring the 2 back, see, I really ran out of space, didn't I? Let me erase what's up top. If I bring the 2 back, so I multiply both sides by 2, what's the final answer? Y equals what, guys? If I multiply both sides by 2, 2. And then negative 32, because you have to multiply that by 2 also. So you could do this without having to find the x-intercepts. But you got to get that 2 out of there first, and then do the rest. And remember, let me get the highlighter here. All this, except negative 16, is all this right here. Those are the same.
This is the same as this, it's just backward, right? That's just backward. Okay.
I think there's one more example. Brady has a question. Can we find the x-intercepts when a quadratic function is vertex form? Yeah, you can. Here's what you do. X-intercepts is when y equals 0, right? And what's f of x? That's y. What's h of x? That's y, right? Y is just the same thing. It's just a different notation. So 0 equals x minus 3 squared minus 25. Now, how would I, and I'm going to just separate from the other part. How would I solve for x for
This guy. How would I solve for x? Check it.
Both sides of the square.
Yes. Excellent.
yes? Add 25 to both sides. I know you guys can do that. But there's going to be 2 answers, though. Yeah, why will there be 2 answers? Now, this is actually a key. Guys, I need you to focus, please. This is the key thing I try to accomplish as a math teacher that is lovely when you guys see it. If you don't, I failed you guys. It's my fault, so I need you guys to focus. Good. If I were to graph that, where's the vertex for that original equation? Where's the vertex? How far do we go to the right? 3. How far do I go down? Oh, geez, yeah. Very, very far down, right? Okay, is this opening up or down, guys? Because A is positive. So when you look, okay, I totally missed. Okay. How many times is graph touching the x-axis?
Twice.
So you need 2 answers. So when you solve for the x-intercepts, you got to have 2 answers, not 1 answer. Okay, because we know graph codes happen. Now you see the graph algebraic connection. That's huge. That's huge when you can see that connection. That's my job. You see that, you're going to be going far in math, at least. I don't know about life, but okay. So if you square root, what are you going to get? What's square root of 25? 5, but plus or minus 5, because you have to have 2 answers. Equals x minus 3. Move the 3 over, and now we got the full solution. Of course, 3 plus 5 is 8. And what's 3 minus 5? Negative 2, good. So you get 8 or negative 2. And my graph made sense, right? Because my graph looked like this, right? Nope. My graph kind of looked like that. So it made sense it's touching at those 2 places. So yeah, cool. Good. All right. So go and try the second one now. I'll tee it up again. So 0 equals x plus 5. So this one's kind of a pain because 8's not a perfect square. Just go with it. So you got to solve for x. Go and solve for x. Do we know the square root of 8 off the top of our heads? No, right? You know. I'll get this. Yeah, so you're gonna rise plus or minus root 8, guys. We don't know. I know it's like 2 point something. Don't worry about it. And then what do I do about the 5? You just push it over to the other side, right? So what's x gonna equal? Yep, there you go. Because you have 5 inside, right? And you have to bring it over. Wait, let me back up a little bit. Sorry, guys. Let's back up. Hold on a sec. Let me erase this. What do you mean by simplify?
Would you not simplify to plus or minus two?
Oh, you could do that too. You want to do that? We could do that. Sure. Look at Elliot, the overachiever. Yeah, totally. We can do that. I like it. So we have root 8 equals x plus 5 plus or minus. Now, do you guys remember how to simplify radicals?
Yes.
Yeah, you know, personally, I don't care, but if you want to, it's totally fine.
Over two. Some people.
So same thing. Same thing. I wasn't sure what you were talking about. Now I do. By the way, what some people do when they do this problem, don't write this down. I'm just going to clear the left side here. What some people do, I'm going to get my stylus because I need to write kind of quick. Some people do this, and I'm a little disheartened. I mean, it's not your fault. Just maybe it was the way it's taught to you. So, you know, then I'll go yell at your middle school teacher. Anyway, some people decide to actually expand this because they feel so inclined. And then they do this, right? And then what can people do afterwards, after they get to this point? We can't, if you can't factor them, what do they do? Yeah, they do quad form, which you could do. But remember, when there are more steps, there's a greater chance to make it careless error, right? And we want to avoid that. So yeah, that's negative. And what if you forget the formula? But if you do it, you get 100 minus 4 times 1 times 17. You just see it's just more work, right? And then you get root 32 inside. It just gets to be really nasty. So some people do that because they only know one way. But guess what? There are other ways you can do it. We want to be efficient. What I just did in red and green was more efficient. So just keep that in mind. Okay. Last bit. Where you guys start homework. You guys should have about 20 minutes or so. Guys, quiet, please. Thank you. This is actually a summary of the whole week. This page right here. So when it comes time to set for our test, sometime in October, I don't have the exact things. October 16th. What's that?
17.
Is it Tuesday?
No, it's
17th is Tuesday? No, we don't do Tuesdays.
I was sure 17th was Tuesday.
Because I just my calendar's gone.
Oh, okay.
No, I know the second.
Can you make it a Thursday?
Maybe. We'll talk. I'm open to that. But anyway, so see here, average x intercepts is how you can find a vertex or complete square. So these are summaries of what we've done this week. Okay. And then some other stuff here too. So anyway, homework is right on the page. Get a head start, especially if you want to watch the Thursday night football game or you got other stuff going on or want to enjoy the weekend. So homework's right here, guys. We got about 20 minutes. Let's get a head start. All right. I'm done. Yep. Yeah, good.